Hey guys, in today's video we're going to cover test levels. It's another quite important area, not only because you're definitely going to be asked about this during your interviews, but also it will be part of your daily routine as a tester. Now, if the term sounds a bit intimidating, don't worry. By the end of this video, you're definitely going to know it all. I promise you that this will be one of the last purely theoretical videos that we will be going through, and purely theoretical areas. Things will start getting much more exciting starting the next video when we will start doing much more hands-on stuff and working on test cases, writing up defects, etc, etc. So stay tuned and let's get right into it. Okay, so as you know, software is built gradually, and thus testing on it is also performed gradually. So like you can't test a complete system until there is a complete system to test. It has to be built first. But what do you do until the whole product or the whole software is available? You don't just sit and idle. There is things you can do, and there's things that you must be doing as a tester. You just basically start testing on different levels of the readiness of the software or of the product that you're working on. There are generally four levels of test that are identified out there, but again, you might encounter a bunch of different terminologies here and there, where one thing might be considered a test level, while in reality is not, or something might be called slightly differently. But in a nutshell, there are four test levels as such. One is called component level testing, then you have integration level testing, then you have system testing, and then you have acceptance testing. So these are the four main software test levels, or in general test levels, even if it's for hardware, that you need to be familiar with. Now let's go through each of them one by one. Okay, so let's start with component testing. Component testing is testing performed on a component level, as pretty much the word suggests. But to explain it a bit better, it's testing as soon as something, even in its smallest form possible, is available or is already built. So developers, for example, will be doing component testing. It's sometimes called unit testing. Most commonly is called unit testing. That's basically testing snippets of their code as soon as they become ready to be tested. Anything that can be tested is tested as soon as it's there. So same applies to the testers. As soon as a small feature, even if it's part of the whole larger kind of thing, is available, you can start testing it. Let's imagine a whole website that you're building together with a large team, let's assume, and there is a login feature, and that login feature has several fields. So it has a login field, has a password field, has a login button, has a bunch of different things, just for the sake of the example. As soon as your login field would be available, for example, and if it's built on its own, and if it's kind of represented on its own, then you do not wait for the whole login page and the whole functionality to be available before you start testing it. You can already start testing the login field itself. Then you do the same when it comes to the password field. Then if any other feature becomes available on the same page. So you test components as they become available. It's the lowest level of testing. This is where you normally begin with testing, and be careful, this is not a test activity that is the lowest level, because there's other test activities which we will go through later, like preparation for testing, documenting test cases, preparing test data and things like this. In terms of the test execution purely, this is the first level that you will encounter, testing components as soon as they are available. All right, integration testing. So, as the word suggests again, integration testing is the testing of the integration of two or more components. So we already covered that you will be testing components on their own as they become available. But these components don't just exist for the sake of existing, they do something together with some other features, most often. And let's explore this on an example. So say again you have your login feature, which in most traditional websites you will basically just go to, put together your login, put your password, hit the login button, then you get in. But also, I'm pretty sure that most of you have seen features, if not all of you have seen features like login with Google, login with Facebook, and things like this. So this is an integration of the website where you're trying to log into with Facebook or with Google. It's different pieces of code located in different locations, connected with each other or integrated with different protocols, which again you don't have to worry about at all for this point in time. The whole point in here is to make sure that integration works. Now there's different ways of doing it. You can do it a little bit less with a black box approach, as in you kind of a little bit dig into the code, not really the code. You kind of do the testing on the level of APIs. And again, don't worry about this much for now, but let's assume you're just looking slightly under the hood and seeing what happens when I click the button login with Facebook. Does our application do something like send a signal somewhere or send a request somewhere to receive some information or whatever else it is? Somehow these two components are integrated together, and that's what you're curious about. You can still test integration of two or more components using a black box approach, as in you just define your final expected result. So you say, I don't care what happens under the hood. All I care about is that once I click on the login with Facebook button, I am logged in to this platform that I want to get logged into. And you don't care about the rest. So you test everything around this feature. You test the actual fact of clicking the button and seeing if you're there. You test something in the periphery, like what happens if my network goes off, for example, when I'm trying to call Facebook to log into this website, and so on and so forth. So in a nutshell, integration testing is testing how two or more components are integrated together to provide us the experience that we are after. Okay, next we have system testing. Now, the logic is just going to continue as we started. So now we have tested each of our individual components, or as many as were available at the time when we were testing them. Then some integrations became available, as in some components required to be integrated with other components, and we tested also the integration of these components. But it's still not covering the whole application that we have, or not the whole system that we have. And system testing is exactly that. It's basically making sure that our whole system functions as it should. And our system is comprised of components which are integrated with each other. That's pretty much it. It's as simple as that. So when you test complete systems, you test from one end to the other. So you identify the first component of your journey within that system, or the user's journey within that system, and then you find out what's the last component of that system. And then you just test everything that can happen in between. And there's different ways to approach structuring your test cases, executing them in an efficient way. There's a bunch of good and creative things that you can do with the test preparation approach, and once you start executing the test cases. But overall, the idea of system testing is testing the whole system on its own. So testing from one end to the other on all of the features which are small components integrated with each other. As simple as that. One more thing to note here is that you could have systems of systems. So you might have one large system which performs a bunch of different things, and that whole system is also integrated with another system. And then in these cases you might also need to be testing this integration. And then if you have even more systems like this, you have to complete the testing of the whole system of systems. But this is all starting to get a bit weird, and you don't have to worry about all of this, but it's just an idea that you can pretty much extrapolate as much as you want. You start with components, then you test how those components interact, then you test the whole system under which there is a bunch of components which are defined, and then you're pretty much done with your system testing. Now let's talk about acceptance testing next. Okay, we're again going to go with what the word suggests. So it's called acceptance testing because certain people or certain interested parties need to accept the software or the platform or the application which has been built for them. And those could be different types of people, essentially, and it's much better to explore it on an example. So let's say we have built an online banking application, right? It might have different people, it will have different people who are interested in using it. First obvious example is the average consumer, so like me and you, who just need an online banking application to be able to make certain transactions, send money somewhere, check out their savings, etc., etc. There could also be a list of users which are operating the platform. So people who just sit at the bank or sit at the organization which runs the online banking application and perform the transactions under the hood, like in the back office of the platform. Administrators of different sorts who create users, help you when you have lost your password and things like this. So these different groups of people and different groups of stakeholders will have different interests, and they all need to accept the platform before it's become live, because these will be the people who will be using the platform end to end and on a daily basis. So if something doesn't meet their requirement, even if it's functional, right? So you have built something which works in general, but it does not meet the requirements of these people, who, by the way, would be also in the very beginning before you even started building this platform. So they would be somehow involved in this way or the other through representatives, through people who know them the best, like this group of users the best. The requirements would be drafted in the beginning. And so in the end, what acceptance testing does is making sure that the platform we have built is meeting the business requirements of all of the possible user groups that might be using our platform. It's as simple as that. Now, how do you make sure that you test a platform instead of all of the users that might be using it, right? Like they didn't just send out Facebook for everyone out there to start testing it before they said, okay, fine, we can go live with our platform. What you do is there's different approaches. Either you can select a group of people from pretty much random people and you pay them to do some testing for you. So they just come in, they use the application, and they see if it's good enough for them. You collect the feedback, you process it. We covered this in one of the previous videos as well, slightly. Or you have people who explore and investigate what the requirements of retail consumers might be, of people, like random people out there might be your target audience. And they think like those people and they test it thoroughly, like with all of the approaches that these people might be wanting to use such an application. And then when it comes to more internal stakeholders, let's say in the same example of our banking application, you have built it and it's definitely being ordered by a certain bank, or the bank has built that application for itself, and it has a department which runs certain parts of this application in the background. So they would pretty much just give the software that is already produced to this group of people or selected individuals from that group of people. It really doesn't matter how it's organized at this point, and they would acceptance test it. You, as a software tester, might be involved in acceptance testing, and very often you will be in cases where there is no representative which can do it for you, right? It's more beneficial not to leave the same tester who was doing all of the functional testing and the component level testing since the beginning towards the end to also do the acceptance testing. The ideal approach is to really find specific people who are as close as possible or are actually the individuals who will be later on consuming the platform or the software that you have produced. I hope this is clear, and this is our last level of testing. But there is one more special thing we need to talk about, and that is regression testing. It's not really a test level, it's something special that can be performed on all levels of testing, but it's crucial for production of any software. Now let's talk a bit about that as well, and then wrap up our video. Okay, as you test the software, you're going to be encountering defects. It's inevitable. And those defects will get fixed. But unfortunately, when developers fix defects, those defects can cause other defects to occur in unexpected areas. Well, not really unexpected, because most likely it will be in the areas where the first defect was originally found and fixed in, but they will, however, cause some things sometimes not to work as they should, unintentionally, right? The developer will just fix the original defect that you have identified and reported, but they might break something along the way. This process is known as regression in software, and there is a process to also control this regression. It's called regression testing, and this applies to all of the test levels. Regressions can occur during unit testing or component testing. Regressions can occur during integration testing, system testing, acceptance testing, on all levels. As soon as there is a bug reported and that bug is fixed, it can cause a potential regression. And same regression testing applies to all of the test levels as well. That's why it's really not a level, it's ubiquitous, it's everywhere pretty much. So you have to perform regression testing on all levels possible and as frequently as you can. However, obviously you cannot just jump back the whole time. Let's say you have tested 10% of the software, then you return and test from 0 to 10% as soon as there is a new bug found, and then do the same at 20%, 30%. You just simply will not be able to do that manually. I mean, in theory you would, but it would require a lot of resources, a lot of people and time and effort involved to get that done. That's why companies normally invest in test automation. Wise companies, at least, invest in test automation, because that way you can basically automate all of the test cases that you have already written up and performed to run as frequently as you want, even on a daily basis. As soon as something is built, all of the test cases which have been written before are executed automatically. Now, you as a beginner software tester, specifically a beginner manual software tester, will not need to know test automation to get a job. That's the whole beauty of this course, and that's the whole beauty of the industry, that you can still quite easily find jobs in software testing without necessarily knowing test automation. I'm just explaining this to you so that you understand how, in theory, can testing be performed so frequently on all levels. But as such, as a software tester, you will definitely be participating in regression testing in one form or the other, even when you do it manually. Most frequently, and a lot of companies are not yet there to have all of their test cases automated for any product that they're developing, you will be performing long regression test rounds towards the end of the software production. In Agile, sometimes they're called hardening sprints. In more waterfall cycles, you will have just a whole regression test cycle. Doesn't really matter how it's called, but as such, once all of the features of the platform are developed, at some point you're going to stop building new features and you're going to only focus on testing what's already existing on all levels to ensure that there are no unexpected bugs, because something that you have already tested and you know that has worked, let's say 3 months ago, and then the software has evolved since then, you have built more features, and now it's about time you were going live. There is no guarantee that the first feature that has been built is now going to be working as it should, because as developers have fixed stuff, they have broken stuff, and you don't know how in the end has it affected the whole application. That's why at the end you will normally perform a large regression test round to ensure that all of the features that have been built and even have been tested before are still working as they should. Okay, so to repeat, regression testing is the process of testing the application or the pieces of the software again to ensure that things that have been working are still working after defects have been identified and fixed on those features. That's pretty much it. Right, I hope this video was helpful to you guys. As I mentioned to you, this will be one of our last theoretical videos. This is an area that you absolutely have to know. But starting the next video, we will start exploring test preparation. We will start drafting test cases together, exploring different approaches of that, and we will get much more hands-on. So it will start getting much more exciting moving on. Stay tuned, and I will be seeing you in the next videos. Thanks a lot, guys.